All right.
Actually,
hey, everyone.
Dan, go ahead.
Yeah, so this is Daniel. So let's get started. I see we do have some attendees rolling in. If you could just start by, just saying hi in the chat. I want to make sure you're all awake, you're all out there. Get used to using the chat functionality. Feel free to ask questions later on. So just wait a second for that. We know this is traditionally, a Chicago meetup. Due to the virtual nature of it, some of you may be attending from the suburbs, maybe from a different state. So yeah, feel free to say hi from, wherever you are, whatever city, and we'll get kicked off here. So we'll start off with some introductions. And speaking right now is Daniel Larkin. I'm a networking sales engineer with Citrix. Joining me will be Steve Lamarre. He'll be tag teaming this presentation with me. He's a lead networking sales engineer with Citrix. And I wanted to give you some background behind this presentation. So Citrix is, half a virtualization company. You may think of VDI, etc. And our other half is networking. So we have an application delivery controller, which is an intelligent, layer 4 to layer 7 proxy, which has consistently been used for, application availability, performance, and scalability. So our customers have been using it to front end their monolithic applications, and they've been transitioning to use it for cloud native applications. And, as they transition, we've been evolving with them, learning how to build cloud native solutions, these microservices-based solutions. And we've learned some lessons along the way. And that's what we're here to do. We're here to share how to choose the right proxy architecture for microservices-based application delivery. So with that, we'll move on to an agenda, give you an idea of what we will be speaking about today. So here's a recap of what we will be speaking about. We'll start with a brief Kubernetes networking 101. We'll go into, a recap of layer 4 versus layer 7 load balancing, why it's important, when you should care, when you shouldn't care, when it's beneficial or not. The importance of choosing the right architecture, who are the different stakeholders involved, what are their needs, when are their needs important. We'll give a brief overview of 4 architecture options that we'll be diving into. But before we dive into them, we'll introduce 7 attributes to judge each architecture. And with that, we'll take a deep dive into each of the 4 architectures and compare them to the 7 attributes so we can kind of see the trade-off between complexity and the benefits. So before we move on, we know we might have a mixed audience here, and that's great in a meetup, so just curious, in our audience, how many of you have a Kubernetes deployment already in production? How many of you are in the early stages? Or how many of you are new to Kubernetes? If you could just put in the chat, prod for production, early stages, or new. Some of us, this is a review to some of us, and others of us are here to learn. And just want to get a feel for the mix of the knowledge set in our crowd. And with that as well, feel free to ask questions along the way. Whoever's not presenting will be monitoring those questions, and we'll find the right time to address them as well. Make sure nothing gets unaddressed. All right. So it looks like we have a good mix of people who are new to Kubernetes, and that's what we were hoping for, and that's why we have these things like the Kubernetes 101 review and all these recaps. So let's go to Kubernetes Networking 101. All right. So we'll take some time on this slide to identify the main, Kubernetes constructs, because we'll be referring to them later in the presentation or later in the discussion, and it'll be important to have a fundamental understanding. So when we're referring to a pod, you can think of a pod as a single instance of an application. You'll have multiple pods for that application. You're building a website, say you have a shopping cart application. That shopping cart will have multiple pods, fulfilling. A pod will be a single instance of that shopping cart application, and there will be multiple pods. These multiple pods will be distributed across your nodes. A node is, you can think of a node as the worker machine. It is a, either a bare metal physical host or something like a VM. It's just it's the machine where your pods live on. So, we have a big Kubernetes cluster. We have our different nodes, our different worker machines. And then when we create an application, it is scattered across the nodes in the form of a pod. An important thing to understand is pods are just like us. They live and then they die. However, they have a very short lifespan. Pods are constantly being created, they're being used, and they're being torn down and recreated. That's the nature of Kubernetes, based on things like availability, based on things like resource utilization, different pods will scale up and scale down. That gives you the scalability within Kubernetes. And what's important here is when a pod comes to life, it gets an IP address. But this isn't a standard IP address. This IP address is only locally significant. It means nothing to anyone outside of your Kubernetes cluster. Even more important is it's not like today where you're on your laptop or computer, you connect to the network, you get an IP address, you close your computer, or you turn off your computer, you turn it back on, you get the same IP address. Because of DHCP or DHCP reservations, it doesn't work like that in Kubernetes. Instead, this IP address is temporary because the pod is temporary. So just wanted to preface that now we can think of two problems here. One, IP addresses are constantly changing. And two, we don't have an IP address that means anything to the outside world for external access. So also, that makes pod-to-pod communication difficult because, if a pod needs to talk to another pod, these pods are constantly changing, the IP addresses are changing. Kubernetes put their bright minds together and they created the idea of a service. So a service is just a logical representation of your application. So you have your shopping cart application in the form of multiple pods. And to speak to that shopping cart application, you'll speak directly to the service. You're not speaking to a pod, you're speaking to the service. And then in return, the service will distribute traffic to the pods. And that's an important aspect because pods are constantly being spun up and spun down, and the service construct is used for external access. So that was a lot right there. I'll pause. Feel free to ask any questions, any clarifiers before we move on. I just wanted to establish this baseline of Kubernetes Networking 101. All right, so let's move on. So now we're going to discuss how to expose your application to the outside world. And we're just setting the foundation before we go into the proxy architectures. So there's three ways you can expose, your application to the outside world. The first is what's called a basic node port configuration. As the illustration shows, you map a node port, you map a port on your nodes, on your VMs, on your bare metal servers, whatever it is. Any traffic that hits that port is going to be forwarded to that service. So we have this limitation of one port per service. So let's think about how we would access this service, how we would access this application. So you have your shopping cart application, which would be those pods. You have the shopping cart service. In order to hit it, you would have to put in a node IP. Your users would have to type in a node IP address as well as the appropriate port. They'd have to put port 30,000, for example. Even if we put a DNS entry that pointed to the IP address, they would have to remember to put in that port as well. We can't use, port 80 or port 443. Kubernetes makes us use, a high port number such as 30,000. So when thinking about how this would scale, this would likely require, a proxy server in front of this, which would then direct traffic to the service. And that's kind of a nice segue into where load balancer comes from. But yeah, just as a quick recap, node port is port per service. You would really only use this if you're deploying like a demo application or something temporary. The second way would be using what we call load balancer. So if you want to expose your shopping cart application to the world, you're now in the bottom left YAML, you see instead of type node port, it would be type service or type load balancer. And now an external cloud load balancer is spun up, and instead of port per service, it's IP address per service. So we have a shopping cart application, we use load balancer, an external, maybe Google Cloud Load Balancer will be spun up, and you'll get an external IP address, and anything that hits that external IP will go to your shopping cart application. Now we have an inventory application. Well, if you would need to spin up a new load balancer. So now we have a second IP address, in a second load balancer. So the two drawbacks there are, we can run out of IP addresses. We're using an IP address per service, and it costs money to spin up all these load balancers. And that is why Ingress has become a very popular way to expose your application to the outside world. You can just think of Ingress as a smart router. It sits above multiple services. So now you have one IP address for multiple services, and it's a smart router. So you can use things like, you can use rules to direct traffic. So anything in a host header, whether it's a domain name, whether it's a subdomain name, or anything in the URL path can be used to direct traffic to the appropriate, backend application, the backend service. In the illustration here, anything with that foo subdomain will go to the foo service. Anything with bar in the path would go to the bar service, and everything else would go to our everything else service. So now we have the ability to have a single IP address to expose multiple services, and it also involves things like third-party Ingress controllers, where we're now getting benefits like SSL authentication, DDoS protections, etc. So I'll pause here. Is Ingress a new concept to some of you? Feel free to put yes or no in the chat. It does warrant a deeper discussion, so I encourage you, if it's new to you, to research it outside of this, as it's key to exposing your apps to the outside world, and it's used in the 4 architectures that we'll describe in a couple minutes here. All right. Yeah, I see a lot of yeses. So yeah, glad we're going over this recap. And I'll pass it over to Steve. He'll take the next couple slides, and we'll dive into layer 4 versus layer 7 load balancing.
Okay, thanks everyone. Let me get the slide advanced. Okay, so the next thing what we would like to do is to really kind of level set the differences between a layer 4 load balancer versus a layer 7 load balancer. So when you look at Kubernetes and the Kubernetes environment, it does provide a layer 4 basic load balancer known as the Proxy, and really it's base fundamental its purpose in life is to take the traffic coming in and forwarding it to the appropriate services or pods within the Kubernetes environment. But again, it is a basic load balancer. It has very limited capabilities. It has very limited, health checking capabilities, session persistence, as well as it lacks, deep packet inspection. But for those who are just starting off with Kubernetes, they want to spin up some applications. There is this requirement for a proxy. It is included, and it actually it gets the job done for what its design purpose was for. But when you look at a layer 7 proxy, this is what you typically deliver your applications today in your data centers, right? You have an ADC that provides that front end, receives all the traffic coming into the data center, and it does the load balancing. And it's not doing load balancing just at layer 4. It has more features and advanced capabilities to load balance at layer 7. So for example, it could take a look at the URL and make decisions on making load balancing decisions based on that. It could actually parse the payload of that layer 7 traffic, and of course enforce policies, whether it be from security perspective. It gives you that session persistence. As we all know, when you're delivering applications and you load balance that traffic or that user to a specific server, you want to make sure that that session keeps on continuing going to that particular server for that application. Otherwise, you can break the application. So I just wanted to kind of get to, some of the differences between what a layer 4 load balancer is capable of doing versus what a layer 7 load balancer is capable of doing, because when you are looking at choosing a proxy architecture for your microservices-based applications, this actually becomes a key component on determining what architecture you're going to choose based on the requirements that you're looking out of delivering your applications in a microservices format. So is there any questions on that? I hope that, for most people, this was, pretty much common knowledge, but I just want to make sure that what the differences are, because we're going to really kind of highlight the advantages and disadvantages of using a layer 4 load balancer versus a layer 7 load balancer as we discuss the proxy architectures. So I'll pause for a second. Okay.
Could you talk a little bit about the circuit breaking capabilities in layer 7 proxy?
So, we do. I know we do have integrations with the circuit breaker. I don't actually have specific information around that. Dan, are you familiar with the circuit breaker capabilities?
No, not aware of it too much either.
Okay. Is that Julio? Was it you asking the question?
Yes, that was.
Oh, okay.
Okay. All right. Thank you.
Okay. No problem. Okay. So one of the reasons why we're having this conversation today with you is that what we're seeing is that many companies are struggling to choose the right architecture for developing and delivering microservice-based applications, and it's really critical that when you make that choice, correct the first time, because with the 4 architectures that we're going to kind of discuss and go over with you guys today, is that once you pretty much take something from a non-prod environment and put it into production, it's really hard to sit there and make that change into a different architecture once it goes live, because the application, it needs to be available to your users, and to make that transition just becomes more difficult. And so what we're trying to do here is we want to sit there and help educate you on the different types of architectures that are being commonly deployed, shows you the pros and cons, the benefit versus complexity, so that you can make the correct decision the first time before you put it into production. Now, with that being said, what we've done here at Citrix is we kind of created this framework with 7 attributes. And these attributes we feel are really important when making that decision, or when you're going to evaluate the different architectures, because it's going to take in the various stakeholders that usually come into play when you develop like a platform team, or your networking team, or your security team. And we're going to kind of cover those stakeholders here in a second, but we're going to look at the 7 attributes are going to be applied to the 4 proxy architectures, and then we can sit there and see what's going to be important to them versus what's going to be important to a different group and a different team, and so forth. Now, before we continue on, I do also want to kind of level set when we talk about load balancing from a north-south perspective versus a east-west. And this is important to distinguish because, again, depending on the architecture you choose, as well as whether you choose a layer 4 proxy versus a layer 7 proxy, you're going to get different benefits and different capabilities from that. So north-south, I think it's hopefully pretty common or pretty straightforward. That is the traffic flow coming in and out of the Kubernetes cluster. And then from an east-west perspective, this is where we're talking about once you're in the cluster, the different microservices applications are talking inside the cluster, like in an east-west type of direction. And so the reason why this is important to distinguish is because you're going to be using different types of proxies for north-south traffic versus east-west. Okay, so we talked about the different stakeholders. So some of these are going to be, we're talking about like your DevOps people, right? When they're looking at an architecture and they're wanting to develop an application, what's important to them is going to be automation, right, and being able to do progressive rollouts. Where from a networking perspective, they're more about policies and being in compliance. And then you look at the developers, they're just about that end user experience and delivering their application to their users. security, they want to be able to sit there and ensure that the application can be delivered to the applications in a secure fashion, as well as protect, the internal organization. And then from an SRE perspective, it's about, looking at observability or having visibility into the application's performance and what kind of latency does occur, what's the availability of the application. And so when you have these different groups or within your organization that kind of make up this platform team, it really becomes important to understand what's going to be important to them and what the architecture is going to be offered each one of these individuals, so that when changes need to be made, when new security policies need to be enforced, you have the proper architecture from day one and not having to make a transition to a different architecture to meet the security requirements or the availability requirements. So with that, these are the 4 architectures that we see commonly most used and deployed. And as you can see, there's going to be a benefit versus complexity. So what most customers typically start off with is a 2-tier ingress design, mainly because it's easy to sit there and set up, it's easy to deploy. You're leveraging a lot of the built-in tools that Kubernetes provides, as well as leveraging your existing layer 7 load balancer that you have in deployment. And so it's, again, the complexity is very low, but also the benefits that you get out of that is low. And again, we'll walk through this here as we go through this presentation. And as you move to the right, we have a unified ingress architecture, a service mesh Lite architecture, as well as a service mesh architecture. So with that being said, does these architectures look familiar to everyone? I mean, have anyone deployed these in production or are looking at them today?
Yeah, very curious to if you do have a Kubernetes deployment or just beginning, if you've chosen one, what's used out there, and
Are we getting, Julio, are we getting any feedback or responses?
And also, if we could go back to the stakeholders slide, yeah, just curious if anyone is a member of a platform team. Do you call it a platform team at your company? And, do you fall into any of these roles? Want to know, what types of stakeholders we're talking to, if any.
Okay.
Right, we see some developers out there. Okay. All right. So yeah, let's move on.
Okay. So as we had mentioned, not only are we going to sit there and look at these 4 architectures, we're going to apply these 7 attributes to each one of these architectures and tell you how it's relevant to the the stakeholders and the groups themselves. So we're going to take a look at from an app security perspective, observability, continuous development, scale and performance, open source tool integration, Istio with the unified control plane, as well as the IT skill sets that are going to be required based on the architecture that you choose. So with that, I'm going to pass this back over to Daniel, and he's going to walk through the the first 2 architectures, starting off with the 2-tier ingress.
Was on mute.
You there, Daniel?
Steve? Yep, there we go. All right, just monitoring some of the questions and responses. So this is where we're going to talk about the 4 architectures. I'll start with the first 2 architectures, and Steve will talk about the second 2 architectures. So the first architecture we're talking about is the 2-tier ingress. On that chart we were just looking at, this is in the bottom of complexity, and the trade-off for little complexity is less benefits, of course. Let me explain what you're looking at here. So in the dotted lines, you can think of that as your Kubernetes cluster. You're going to deploy applications. Your applications will be essentially pods that live across all these different nodes. So that's the first basic description of what you're looking at. And as you can see, it gets the name 2-tier ingress because we have 1 tier at the top, one tier of proxy. That Citrix ADC is, for example, that's our, load balancer, our layer 7 proxy. It doesn't have to be a Citrix ADC. It could be, whatever third-party proxy you choose. But tier 1 is external to the cluster, whether that's a physical piece of hardware or a virtual appliance. So that's tier 1. Tier 2 is a containerized proxy that lives within the cluster. So it would be, some pod within the cluster. It's a container in a pod in the cluster. So that's where the name TwoTier Ingress comes from. So how does traffic work here? The client sends a request. It hits the tier 1 ADC. The tier 1 ADC will send the traffic to the tier 2 ADC. And ADC proxy, ADC stands for Application Delivery Controller. Just ADC, load balancer, proxy, they're all synonyms. So, your client will will hit the tier 1 proxy, which will forward it to the tier 2 proxy within the cluster. And then it's the tier 2's job to send it to the different microservices. So that's how north-south traffic is handled. That's how traffic comes in and out of the cluster. Microservice to microservice communication in this architecture is handled by kubeproxy. That's the default, basic layer 4 proxy, that open source proxy that comes with Kubernetes. So some important things to call out here is in this architecture, our tier 1 proxy is managed, by your existing networking team, just like they manage it today. Not much needs to be changed there. All they need to do is point it to the tier 2 proxy inside of the cluster. More of a set it and forget it type things. Meanwhile, your platform team has their own dedicated tier 2 proxy that they can make changes with, that they can spin up and spin down, and don't have to worry about affecting the tier 1 proxy. So I'll pause here, see if there's any questions so far, any comments. So let's bring up the 7 attributes on the right to see the benefits we're getting here. In this type of architecture, a lot of the benefits are going to be north-south. We're using these intelligent, layer 4 to layer 7 load balancers, these proxies that have advanced capabilities. When it comes to app security, they have built-in capabilities to do authentication, SSL, DDoS protections, web app firewalls. So we get those benefits for traffic coming in and out of our cluster. But when it comes microservice to microservice, that east-west traffic, we have little benefit. We're using the default kubeproxy, which has its limitations, and to improve our app security, for example, we would rely on third-party solutions. For example, we have listed Project Calico. Next, moving on to observability. That's referring to, seeing the latency of transactions, tracing a transaction to see, how the client comes into the cluster and what specific pod they land on. So same thing, north to south, any traffic coming through our intelligent proxies, that information is easily exported into various tools to get information on north-south traffic. But when it comes to east-west, there's limited telemetry. So the next 2 points, continuous deployment and open source integration, they're very similar. So jumping down to open source, a lot of, depending on the proxy of your choice, they're constantly making sure they're integrated with a lot of open source tools. For example, for continuous deployment, a lot of third-party proxies are making sure they have tie-ins with Spinnaker and Kayenta. So in terms of north-south traffic, your CD pipeline can be managed, but east-west, again, the common theme here is kubeproxy has its limitations. And the final thing to call out is IT skill set required. We have this segmentation of responsibilities in a 2-tier ingress. Tier 1, the networking team's responsibility, just like it is today. All they need to do is point traffic to tier 2, and the platform team can take it from there. The platform team is used to handling their tier 2, containerized proxies, They don't need to get hands-on on tier one. So there's minimal cross-pollination. It's just so when it comes to complexity from a business viewpoint, we see that as the least complex to get set up. I'm going to pause here and check out some questions. Any questions on two-tiered ingress before we move on to the next architecture? And we'll be able to share, some of this deck after, if you're looking for some of the hyperlinks that were contained within, or just want to review the content. We'll be happy to share this after this presentation. All right, let's move on to the next architecture. So this would be unified ingress. It looks very similar to the last architecture we showed. Instead of having two tiers of proxies, we just have one unified ingress, hence the name. And this is, we consider the benefits are very similar to the previous architecture, but we consider this to be more complex. And you may be wondering, there's no tier 2 component. There's less components in this. Why is it more complex? And we'll explain that. So in a unified ingress, like I said, you just have one external proxy, one external, load balancer residing outside of the cluster, and north-south traffic, instead of being passed to a tier 2 proxy, traffic goes from the client to tier 1 and then directly to the microservices. So a couple considerations here. Instead of just poking, one hole into the cluster into tier 2, now we have to poke multiple holes to all the nodes. So that's one reason it's more complex. And additionally, you have both your networking team and your platform team, hands-on on the tier 1 ADC. Instead of having tier 1 for your networking team and tier 2 for your platform team, they now share an external load balancer. Maybe they're slower to make changes due to change control processes. And now your platform team needs to be networking savvy. They need to be aware of, any changes they make to ensure they're not affecting other portions of the business in case that, proxy is being used for things outside of their Kubernetes cluster. So let's bring up the 7 attributes, and we're not going to go into each one, but, the common theme here is very similar to the first architecture. We're getting all these north-south benefits because we're using an advanced, layer 7 aware proxy that can do SSL authentication, has security benefits for north-south traffic. But again, microservice to microservice, east-west, handled by kubeproxy, that has its own limitations. And then, in terms of complexity, now we have a platform team who needs to be more networking savvy. They're more hands-on on the external ADC. More holes need to be poked into the cluster to get traffic from outside to inside. So, from a business complexity standpoint, it's a bit more complex. Of course, if you were, standing this up in a lab or something, this would probably be the easiest thing to do. So those were the two first architecture. We have two-tier ingress and then unified ingress, which is, a variant where there's just one tier. Any questions before we move on? So I'll pass it to Steve here, and he's going to be going over the next two architectures. And, here's where we really step up the complexity, but of course, in exchange for some benefits. So go ahead, Steve.
Okay, thanks, Daniel. So yeah, I'm going to first take a look at the service mesh architecture, which is considered the most complex, but at the same token gives you the most, the best benefit. But first, what I want to point out is when you look at this design or this diagram here, if you notice when you looked at the first two architectures, the dotted line represented a Kubernetes cluster, and then you had your nodes within the cluster. With the service mesh, we need to take it into the next step or the next layer and really look at it from a node perspective, because what we're doing in this architecture, or what is being done in this architecture, is that you're removing that basic layer 4 load balancer known as the Q proxy or HA proxy or what have you, and replacing it with a layer 7 load balancer and a sidecar. And so what this means is that each pod running on each pod on the node is going to have its own load balancer sitting in a container with it, and when it communicates to other microservice applications within that particular node or within the cluster, it'll be load balanced through that particular layer 7 load balancer. Now, to kind of point out, when you look at it from outside the cluster, you still have, the network team managing the network side, as well as the platform team, managing everything within inside the cluster. But really, the key, the big difference here with the service mesh is the sidecar concept. And so what this does now is that the limitations that a layer 4 load balancer has gets removed, because now you're going to have a more advanced load balancing capabilities. So now when you look at it from an application security perspective, not only are you going to be able to enforce your security policies like you have been on the north-south traffic flow between the green and the blue Citrix ADC CPX, but now you're actually going to be able to enforce those security policies with that advanced layer 7 load balancer and the sidecar for that east-west traffic. And the same thing holds true from observability, right? As microservice applications pods are being spun up, spun down, having visibility into what the latency, what the performance was as communications between the microservices are taking place, you're going to be able to have that now, because again, you're going to be able to collect that telemetry. You're going to be able to send that to a management platform, and then your SREs are going to be able to gather the information that is important to them to basically monitor the performance of the application. Same thing holds true with continuous deployment as well as scale and performance. Again, having that layer 7 load balancer just brings so much more capabilities to the environment. And now with the open source tools, because a lot of the tools that are available don't really support the Q proxy. Now with again, advanced layer 7, you'll have that capabilities. But really, one of the big downsides to this is that there's going to be a steep learning curve for the platform teams, because now they're getting more into the networking side of not just from within the cluster, but with the different nodes, but now you're within the pods within the nodes. So it adds a little extra complexity. But again, the benefit is that you're going to have the best observability for all traffic flows, north, south, east, west. You're going to be able to implement the best security, have fine-grained traffic management between those microservices. So any questions around this, around the service mesh? It'd be interesting to know if anyone's actually gone to this architecture from day one, or maybe they may be considering making that transition here shortly based on what their original decision was. Okay, so I'll go ahead and move on to the next architecture, which is what we refer to as the service mesh Lite. Now, again, this is very similar to the service mesh, but it's going to remove some of that complexity that is present in the service mesh. Now, again, same concept where the outside of the cluster is going to be managed by the management team or network team, inside the cluster, the platform team. But as you can see here, what we've done, again, we're still looking at it with inside a node and the various pods that are running within that node. But the difference here is that you're not running a sidecar on every single pod. So we're removing that complexity and just putting in a centralized ADC or advanced layer 7 load balancer within that node, and then having all that traffic run through that internal load balancer. And so what this does now is, again, it removes that complexity, but it also still allows us to have all the visibility, because all the traffic is going to be flowing through that from an east-west perspective, as well as the north-south. So again, very similar to the service mesh. You're going to have excellent security capabilities, both north, south, east, west. Same thing with observability, continuous deployment, scale, performance, and such. And really, the key difference here is the reduction of the complexity from the number of ADC or proxies that you have to deploy within the Kubernetes environment, as well as that has to be supported. And so we look at it from an IT skill set perspective. You're kind of keeping the training for both the platform teams down and the network teams down to a minimum, so that they can sit there and just focus on their areas of expertise. And the other advantage to this architecture is that if you did start off with a two-tier ingress architecture, which is very common and very popular, and you're starting to realize that the limitations that are being placed upon that layer 4 basic load balancer is really kind of hindering your ability to transition this application from a non-prod environment to a production environment. It's very easy to sit there and transition that architecture into a service mesh Lite because of the similarities in regards to where the layer 7 load balance resides, and then how to sit there and configure and set that up. So what we see is that this is probably going to be the type of architecture that most companies and organizations will start to gravitate towards, because it gives you the best benefits with less complexity of going to that service mesh. It's going to be able to allow all the various stakeholders within that's part of your platform team, because again, we've seen every company has different members that kind of make up the platform team, but it's going to give them the ability to, your networking team, your DevOps team, your security team, giving them the ability to use tools that allow them to do their jobs and have them, be enforced within this microservice-based application. So to kind of sum it up, we talked about, the 4 different architectures, right? The two-tier ingress, the unified ingress, the service mesh Lite, as well as the service mesh. We looked at each one of these architectures from the 7 key attributes that really takes all the stakeholders that are going to have a stake in the game, and kind of showed you what the pros and cons are of each one of them, the benefits that you get, the complexity that's required, so that hopefully, this was, educational for you, that it kind of gives you some ideas to think about when you make a decision on what architecture you want to maybe change to in your non-prod environment today before you move it into production. Because as you can see, if you started off with one architecture and want to go to another, there's going to be not only a level of complexity, but you're going to have your internal challenges with change control management and such to accomplish that. Is there anything else you'd like to add, Daniel?
No, just wanted to point out, I put some links in the chat. There's a unified Ingress demo in there, some information on Service Mesh Lite. I also included a link to that article we referenced in the beginning, talking about the different ways to expose your applications. And yeah, I just wanted to share those useful links with you. But yeah, let's pause here. Is there any questions, anything one of you missed or would like us to go over? Maybe we missed one of your questions.
From a security perspective, what are the capabilities for custom authentication tokens that the CPX can handle? Or
so the CPX, so the Citrix ADC is in general, it's a software-based load balance. It's always been, and the feature sets that's available on our physical hardware as well as our virtual, VPX hardware, is the same type of feature sets that you can have available onto the CPX. So depending on what authentication protocols that you're looking to use or leverage, we have that support integrated into the CPX. So is there a specific authentication
you're looking
at?
And to add to that, the CPX in these type of deployments is frequently used as, an API gateway, whether that's whatever authentication mechanism you're using, whether it's like a JW token, something like that, has a lot of capabilities, if that answers your question.
Yep, thank you very much.
And that's a good point, because that's a big piece of using, an intelligent third-party proxy, those advanced authentication capabilities, those API gateway capabilities. You won't need a separate API gateway component you're getting your load balancing, you're getting DDoS protections, and then, in the same appliance, you also have API gateway functionality.
Are there any other questions?
All right. Yeah. So why don't we show the next slide? We'll leave this slide up. First, thank you for listening. We got some great feedback from the audience. We appreciate you sharing your insights, whether you are new or experienced with Kubernetes and the different roles that you have at your company in standing up a Kubernetes environment. Steve and I, in my email, are on the screen. Feel free to write it down and reach out if you want to, follow up privately after this. And yeah, we have some resources. Citrix provided some resources for, our Ingress controllers and other components on GitHub, if you'd like to check that out there.
All right. Well, I'd like to thank you guys, Steve and Dan. The presentation's been great, and thank you everyone who's attended today. These meetups wouldn't be possible without great presenters and topics like yourself. And so I invite everybody in the audience, if you have any topics that you can think of, meetups are a great way that you can demonstrate either some of the projects or frameworks or ideas that you work with to a larger community like Chicago Microservices. So please, if anyone has topics for the future, reach out to us on our Meetup site and we'd be happy. Other than that, thank you very much, guys.
Thank you. Everyone have a great day.
Yeah, thank you for hosting us.